Adam, restart the slides because I removed some miscellaneous that was empty.
Oh, okay.
Gorka saw that.
Thank you. Hi, welcome everyone. This is Witnet Sprint Review number 42. Thanks for tuning in. As usually today, we will be giving an update first on community and outreach, and then on software development. And this time we have a very special demo from our special guest, Dr. CPU. So keep tuned until the end because it's going to be exciting. And finally, we will be doing questions and answers, and also our funny meme art gallery. So without any further ado, let's start with community and outreach update.
Great. So we are. So first of all, we've got a new Slido app, which is for asking questions and for voting on polls, including the community meme competition at the end of this. So I've included a link in Telegram, and I'll be posting it on Discord in a minute. So just ask any questions on there. There we go. Could we head back to the slide, please? Thank you. We've made, so just go to slide.do, Slido, and use the event code Witnet42, or see the link posted in the YouTube comments in a minute. We've made a lot of progress on the Block Explorer and the network dashboard. The Block Explorer will be going over in the demo today. Dr. CPU will be going over it. You can go to community channels in Discord or community tools in Witnet in Telegram and get involved and help out with the projects. So here's a sneak preview of the network dashboard from that Harsh, Jane, and Bertrand have been working on. As you can see, we can see all the nodes on the network with their mining. The last blocks, transactions, last block time, application, and their uptime. You can pin specific nodes that you want to be watching. All their recent requests, data requests. Number of active nodes, commits, locations, number of active nodes with reputation, last block time, and the split. Great. So specifically with phase 2, this last sprint, we've opened contributions. So for anyone that hasn't seen that yet, go to testnet.witnet.io/contribute. We have a set of instructions to contribute various different things to the network. We have different amount of allocations, mainnet WIT allocations for various different tasks, ranging from technical to documentation to community. So just head to that page and you can find out. You can see all the current tasks that are available. We've had 10 preset tasks have already been assigned. We have 4 still open, and there'll be more coming in the next week. But yeah, check it out as soon as possible and assign yourself to any that you feel would be fitting. If you have a contribution that's not on the board, just get in touch with us. We'd be happy to discuss it and set an allocation. These are only our recommended ones. There are also, there are various different ways depending on your skill sets. that you can get involved. We've now picked a company to carry out the KYC. So there'll be more details coming in the next sprint. So upcoming sprint, we'll be launching 9.1 next Tuesday, this coming Tuesday, 14th of July. And block counting will resume, as we've said in all our announcement channels. So blocks mined during testnet 9.1 will be allocated Witnet tokens. You can vote on the preferred start time on the pin post in the Witnet Telegram. And voting now closes today because we want to make sure that we give everyone enough time to update their network over the weekend. The KYC, as I said, will be coming this sprint. So look out for details in your inbox, and we'll get, hopefully as soon as possible. We've just got to finish some final details, and then we'll be sending it out. And the bug bounty details are coming next. So if anybody that wants to find bugs, wants to try and break the network, or various other bounty tasks, we'll be putting a Medium post up in the coming weeks. And we'll be setting allocation for the dashboards, for the Block Explorer and the network dashboard, which will be run by .cpu, and we'll be giving further details on that in the coming weeks.
So regarding software development, in the node, our main goals were sanitizing packaging, basically making sure that having peers that are not reliable don't bring our node down. Doing some assessment on basing the consensus protocol of Witnet into the super block thing that we have now, which we implemented for the bridge with Ethereum, but we are finding it quite useful also for this, and also improving block validations so that they take way less time to propagate through the network, and also to make sure that we do as little computation as possible when we are validating block candidates. Then on the Sheikah side, assessing Spectrum as our go-to solution for end-to-end testing, and also allowing Sheikah to export data requests as JavaScript so that you can import that into your Solidity project using our Truffle box. So going into detail with Sheikah, Thomas will be explaining.
Well, as Adam said, the main goal for this sprint was assess Spectrum as end-to-end test framework. And this is come from the necessity of remove Cypress as our current end-to-end test library, due to we have to import Electron dependency in the Sheikah frontend, and Cypress doesn't support it because it needs a Node.js environment, and Cypress needs a browser environment, so it made it incompatible. So during this sprint, we tried to include the Spectrum in Sheikah, and we found that the time needed to make it work with our current stack, that is Electron with Vue and Element.js Element UI library, isn't worth it for the time we will save having those tests. And because of that, we are not going to continue working on that. And we save the work done as a not finished proof of concept in the branch in the Sheikah repository that you can check if you are interested. And on the other hand, we also export add the functionality to add to export data requests as JavaScript compatible with the Truffle box from the data request editor. And we also fixed some bugs in the Witnet read.js library. Now you can update nested arguments inside other arguments. For instance, if you are trying to update an argument of a subscript, and you also can use map filter operators with an already defined filter function, or with a custom subscript that you made.
Cool.
Okay, in the node, as Adam said before, we had been focused in solve the issue that found in the testnets 090 ABC. So we have created a nice bucket where send and that those that are out of consensus or down to improve the velocity to find the new good pairs in case of needed. Anyway, these iced pairs will be melted in a specific period that it's not can configure. We have implemented an inbound civil rejection that do not allow to have more than one inbounds that are the first two octets of the IP addresses to prevent your inbounds being monopolized by a single IP range. And also previously, we received all the candidates and later the node decides which is the better candidate to consolidate. Now that validation is done as soon as block is received. And if a block has a low priority is received after that, it will be rejected without validation. So it also prevents to share multiple low priority blocks by the network. And yeah, we also modify the logic of the node when it loses the consensus. Uh, um, Now, if a node is synced and loses the consensus, the node will go to the almost synced. This is a state where the node can validate and consolidate blocks, but not mine it. In that way, we keep the state of the network and reduce the possibilities to be forked until achieve a real consensus with the outbounds. We also include the superblock in the last beacon for new consensus ways, but it will be explained better by Claudia after that. And finally, under review, we have we have a PR to sanitize the transactions mempool to avoid to have invalid transactions in our mempool, and it allows to improve the transaction validation process. And yeah, that's all.
Okay, can you hear me?
Yes.
Yes.
Then in the research area, what we have done is doing some analysis about concerns that we had about the consensus in Witnet. So the situation right now is that we have, apart from blocks, in each checkpoint, we have members of the active reputation set that propose super blocks, and these super blocks can be thought as a summary of the blocks that happen between those checkpoints. So some research that we have done about options that we could include in Witnet are, for example, superblock proposers. As I said, at the moment are the active reputation set members, but this could be a subset of that set. Then doing some research about the different finality options that we have, how to synchronize after a fork, and how to avoid a fork, and then if a fork happens, and how to go back to the main chain, and then how to avoid attacks such as denial of service, rogue key attack, or long range attack. All of this has done so that in the next sprints we'll have an assessment from which we'll take the next steps to start from.
With respect to the sprint summary, we had, as you can see in the chart, we had a bit of a slow second week in terms of implementing new features, but mainly the reason was that we wanted to devote enough time to make the testnet 9.1 as resilient as possible, and that means that we need to do quite a lot of testing. We believe we got a pretty solid release, which will be available in the next hours, as Thomas said. But of course, some of the features that we wanted to include have been taken out because from the release, because we wanted to make further testing on them. And as the main impediments, so we have detected some bugs that we didn't know about while we were, for instance, sanitizing the bucketing, etc. And those had to be fixed. in terms of Sheikah, we devoted a lot of time in finding the, as Thomas said, the right framework for end-to-end tests, and yeah, basically that prevented us from putting attention in other issues. And also, as we already said, since we wanted to make the release as solid as possible, we devoted quite a lot of time doing tests for test 9.1, especially the bootstrapping scenario.
So now we will be demoing the Witnet Blockchain Explorer by Dr. CPU. It will be Dr. CPU who will give the demo. So I will stop sharing and allow him to do so. Are you ready?
Yeah, let's try this. Okay, can you see this?
Nice and clear.
Okay, perfect. So well, this is the tool I've been working on together with ParityBit. So the goal is to give an overview of the network, of the number of blocks that have been mined, the data requests, pending requests, all the blocks that are currently part of the blockchain, and the data requests that are executed. So there are a couple of features. You can search for specific blocks. So you can see that the block page just updated. Let's go to a random block. So this shows the block hash when it was minted, the lucky guy that actually got the reward, the address of it, and the transactions that were included in the block. This is on the new testnet, so it's still pretty boring, only shows a mint transaction. But let's see. We can also look at the data requests. So this was a data request I sent into the network about 10 minutes ago, which queries for the Bitcoin price. It will show basically every field that the data request contained. And then we can go look at the at which nodes committed to giving an answer to that data request. So this was this node and this node. They have revealed the value 9,173 for Bitcoin, so it has dropped a lot since a couple of days ago. And then in the end, we can see the tally result. So the result that has been returned for the data request was longer than expected. Okay, there we have it. So there is apparently one lucky guy that was able to mine 4 data requests, and all the others are slightly lower on the ranking. Let's have a look at the 9,100. This takes a while to gather. There is apparently one able to. Let's have all nodes in the network that have a non-zero balance in a number of widths. So there are a couple nodes that have a lot of blocks minted and thus have a pretty big balance. Let's look at one of my addresses. So this is looking at the at my node. So I have minted 12 blocks for which I received the number of widths. These are all the blocks. I was unable to solve any data requests, but I did execute a couple of data requests. So I sent those into the network, and I also added a couple of value transfers to the network. So I'm going to try something. So I have just sent a value transfer and a data request into the network. So let's hope it turns up here, and I'm lucky. So this is the data request I just sent into the network. And this is the value transfer I just sent into the network. As you can see, I'm again asking for the Bitcoin price with some parameters. And I also sent one width to another address of mine. So by now, so the requests are still pending. So let's hope they get included in the next block. Okay, so they should be in the next block. You can see it here. That the data request was entered in the current block. So we can, again, look for a data request. These were all the details that I asked for. There are no commits and commit reveal or tallies again yet, because, well, we have to wait until 4 blocks in the future before that shows. I think those are pretty much all the features that are currently added into the Block Explorer. So the code is currently on GitHub, but not public yet. If you want to collaborate on this, feel free to ping me on Telegram, Discord, whatever. And if you have, definitely test the Blockchain Explorer and give me feedback whenever you want. It's still very much in a beta stage, so there is a high possibility of it crashing. If you can share reproducers with me, that would be awesome, because testing this complete project on my own is proving to be, well, difficult. So I guess that's it for me, and we can go on with the with the presentation.
Thanks. That's been great, really great. So time for questions and answers. Please shoot your questions at slido.com. The room code is Witnet42, and we have when testnet. Yeah, next Tuesday. We are super happy that we are finally resuming the block counting. This time we think it will last longer. For sure, longer than the last time. There are a lot of changes. We will explain them in more detail with the announcement, and the instructions for upgrading will be the same as usual. You know, basically stopping your containers, removing the containers, doing the Docker pull Witnet/Witnet Rust thing, and then recreating the containers with the Docker run command. And very little more, but we will, as we usually do, again publish these instructions and everything you need to take into account for making sure that by the time we are rebooting the network on Tuesday, we are everyone's ready, everyone knows it's running, and they are appearing correctly, and so on. Okay. So more questions coming. When moon, hahaha. This is a community full of meme lovers. Patty asks how is that, in this case, the Block Explorer, I guess, how is it retrieving information from the Witnet chain? You want Dr. CPU to explain?
Yeah, sure. So there are a couple of components to the Explorer. There is a Postgres database, which will basically index all the transactions, all the blocks that are added to the chain. And so using some SQL statements, I can link those together. Also, for getting more details about the data request, I usually use the RPC, the JSON RPC interface that is provided by the Witnet node. So I have to run a Witnet node on my server, and then the Block Explorer will just query that node whenever you're asking, for example, for a transaction hash or a block hash or a data request. I guess that's more or less an answer to your question.
Super cool. Okay, any node limitations per IP on server? It's here. Oh. Okay, this one. Yeah, someone was asking about, yeah, node limitations per IP on server for 9.1. For 9.1, what the major change regarding that aspect is that if I'm running a node, I will have, when I'm running a node, I have out inbound connections, so connections that my node opens to the rest of the network for downloading blocks and for getting like a neutral view of where the network is and so on. And on the other side, we also have inbound connections, which is basically the other side of the same connection. When I'm doing an outbound connection, the peer, the other node to which I'm connecting, will see that connection as inbound. So with this new release, there are two main changes that affect this and that will have clear consequences to the idea of running many nodes in the same device. One is icing, which means that if my node tries to connect to another node and it fails because it's out of consensus or it's down or whatever, it will keep that address, that peer address, in an ice bucket, so that basically it's like a list of addresses that will not be tried in the next 24 hours, so that we are not constantly trying to connect to nodes that are not performing. And that's one thing that's super helpful for actually discovering which are the peers that you can connect to. And the other one, which is the one that has the biggest impact on running multiple nodes in the same device, is that if I'm running a node and I already got a connection from your IP, I will reject any more connections from the same IP. So for example, if you are running 100 nodes in the same device, which never was the best idea in the world, I will get a connection from your first node, but then reject the connections from all the other 99 nodes, and they will need to go somewhere else. They will need to find some other peer that had no connections with them for them to accept those connections, and so on. So don't be surprised that if you try to push too many nodes in the same device, they will get poor connectivity. This is something that we always explain, that is in the documentation. It has been there for 2 years. It's a thing called bucketing. It's the same as Bitcoin does. And this is important because it makes your node not reliant on single point of failures. So the idea is that you have your connections are as diverse and as spread across the network as possible, so that if a part of the network goes down or a particular node operator turns down its VPS or wherever, your nodes will not suffer from that, because they will lose only a small percentage of the connections and everything will continue to work just as expected. Okay, it's here is asking why no proof of work or proof of stake. Yeah, this is a decision that was made very early on, and it has a lot to do with barriers to entry. In this case, for the way that the data requests are resolved to work, it's important that the node operators are as diverse as possible, that we have a broad pool of nodes from which we can randomly select a few for resolving our requests. So it's important that there are hundreds or thousands of different nodes in the network, and that they are reliable enough. So basically, if we resorted on standard proof of work or proof of stake mechanisms, we can expect a number of node operators and a concentration of the node operator task, which is block producing, and in our case, resolving data requests, that would be a lot of super concentrated into a very little amount or number of node operators. And that's a huge risk in terms of having a solution that is actually decentralized in terms that no one can tamper with the information that is being retrieved and aggregated and delivered back to smart contracts. Because otherwise, if someone has a lot of machines that they can put there, or a lot of computing power for doing proof of work, or a lot of stake, they could take a significant part of the network, and they could, without any sort of slashing or whatever, they could perfectly alter or modify the result of a data request, and that's simply not acceptable in our case. So we are resorting into a different mechanism for consensus that has not such reliability on your computing power or your economical stake. It has some reliability on that, but it really lowers the barrier to entry, so that a huge number of node operators can be accommodated by the protocol. And okay, Oyer is asking about whether all the development is happening we are doing everything with Rust, or is there any development in any other languages, because he would like to contribute. First, thanks for your willingness to contribute. So the node software, basically the software that you need to run for having a node in the network and resolving data requests and trying to produce blocks and so on, is written in Rust. But for example, the part that Sheikah, this component, which is the wallet for Witnet, and also the visual editor for creating data requests and so on, this is using JavaScript, actually TypeScript. So that's probably more welcoming for someone who is more into web development and that area. And yeah, and we also have some tooling in Python. We have a broad set of contracts that allow for the interaction with Ethereum, which are obviously written in Solidity. So there are many opportunities for contribution there. Okay. Oh, our friend Bertrand. Would we prefer a common stats dashboard where all nodes connect to, or including it in the Docker Compose integration to start it aside the node? Yeah, I don't know. Both would be useful, and yeah, that's something that we need further to discuss and collect feedback from the community on which makes the most sense. So Anonymous asking, not a good idea to flood one server with 100 nodes, but it still makes sense to set up 3 or 5 nodes per server. And there's documentation about how to run multiple nodes. That's totally something you can do. Just to let you know that the protocol is designed to give you an advantage in operating a smaller number of identities in the protocol than running hundreds of them, or even a few. So with these new changes, we make sure that if you start with one, you will be good. If you start with 3 or 4 or 3 or 5, as you said, you should probably initially you will only get one of them synchronized, but as the network grows, it will be able to accommodate more and more of your connections, and 3 or 5 will probably be good as well. But that's something that we need to try on the actual network in the coming days and weeks. Regarding hardware requirements, you can find that on the documentation. Normally, 1 GB of RAM in one CPU is assumed to be like a minimum safe for running a Witnet node. And Yeah, Nekane asks, what if their nodes are in the same IP range as some other node not run by me? That can happen. Yeah, that can totally happen. That's something intrinsic to the bucketing system. That's how it works in Bitcoin or Ethereum. And as I said, as the network grows, there's more capacity for nodes to receive your connections, so it becomes not a problem if there are a few nodes sharing the same IP range, that which is something that could easily happen. For example, if I'm running a node at my home and someone else is running a node nearby with the same internet service provider, their IP will most likely look like mine, and if I'm already well connected to the network, they will have a disadvantage in that sense. But if the network is big enough, that will not be a problem. So I think we're done with questions, but what we will be doing at the Slido, don't close the Slido yet, because we will be doing a poll about the memes. So first, let's see the memes. Okay, so there are some internal memes, some produced by the developers and the people from Stampery Labs, who are in charge of the day-by-day operations of the software development. And then we have the community memes that you have contributed through Telegram and Discord. Keep them coming, please. Those are great.
We're seeing the slide.
Oh, thank you. So there we go.
There you go. Yeah, most of them are regarding the new bucketing system.
Where is NTP?
Yeah, if someone was concerned about the node whales bringing like dozens of thousands of nodes at the same time, we will speak in a week from now. Some things are changing. As I said, it's important that everyone gets the opportunity to run a node and to propose blocks and get them accepted and resolve data requests and so on. And it's important that that power and the reputation score in the network is not concentrated in a few nodes. That's crucial for the viability of the protocol and the network in the long term. So for the community sprint memes, this week, this sprint got really good ones. Oh my God. So, okay, these are the options. I will enable the poll. I think I can.
I've just enabled it now.
Perfect. So, yeah.
If you leave those up, then just vote on 1, 2, 3, 4, or 5 on the poll.
I'm voting myself.
Music for voting.
We have a clear winner.
Okay.
Great.
Shall
So the
we-
winner is number 5, which is Dr. CPU. So congrats, Dr. CPU. It's been a big sprint for you.
So thanks everyone for watching. Thanks for your questions. Thanks for your support. Thanks for all the contributions. We are really happy with how this community is evolving. Really thrilled about having a new testnet release coming next week. Really looking forward to resume the block counting and resume the rewards distribution. There's a lot of stuff that is coming in the next weeks. We have also started to work on the features for the 9.2 release, which will be really focused on improving the consensus mechanism and polishing that so that we are ready for an eventual mainnet release really soon. And yeah, lots of things to be excited about. Also about our colleague Mario, who just had a baby. So congrats to Mario about that. The Witnet family is growing. And yeah, see you next sprint review. Have a great weekend and have a great week and everything. Thank you, guys.
Thank you. Bye.